Hello, I'm going to go through the worksheet that I gave yesterday, 4th September, okay, the one on A maths differentiation and integration, okay. I will go through this whole paper within this video, and subsequently, right, the videos will include the discussion of all your prelim exam questions, okay. When school opens, we will basically just I will just let you check the marks. I won't be going through each question, okay, because I'm going to go through the questions, how to do and all that in detail in all these videos, so that everybody can understand, and then when I rush through in class, you won't if you are shy to ask, you can refer to the videos, you see. Okay, so that's the purpose of having the videos to help us do corrections. All right, now the other thing is, for once school reopens, we will be doing other school prelim papers. Okay, so for this September holidays, if there's any concept you're not sure, please Zoom with me and then I will clarify all your doubts. Okay, now let's start. Now the equation of a curve is given by this. Okay, so they ask you to find an expression for dy dx. Now the questions here are very O level. So you see, this is a function, this is also a function, 3x is a function, right? So it's a function divided by a function, so you have to use a quotient rule. Okay, do not bring up this 3x and then you try to use product rule and all that. Don't, because you introduce a lot of negative and you will complicate your whole working. All right, so let's see how we do this. The template is like that: minus, then whole thing square at the denominator. Okay, now you differentiate this e to the power of 2x first. So differentiate this is whatever you see is, you just write here. Differentiate the so-called function here. Now you get 2, don't touch the 3x. Okay, then minus, now you don't differentiate this, you just leave this here. Differentiate 3x, you will get 3. All right, now after this, let us try now to simplify more efficiently. Okay, from your prelim paper, many of you actually do double work. Now let us see how we can do it. Now you can use a pencil like me. Do not use a pen, use a pencil like me. I'm trying to take out common factor now. So if I look at the numerator, e2x I have here, I have e2x here, so I can take it out, right? Okay, other than that, any other common things here? I have x here but no x here. I have 3 here and I have 3 here, so I can take out 3, you see. So you do things systematically. This one same as this one don't have common. Yes, 3 we have common, x no common, so you can take out 3e2x. Okay, and whatever I did not take, leave it behind. All right, now take note, there's actually a 1 here, so this is not 0, you know. All right, so it must be a minus 1, so that when you multiply back, right, you get this, multiply back, you will get this whole thing. Okay, and of course the denominator you expand, you will get this, and always leave in the simplest form. All right, many of you didn't do that in the prelims. Simplest form, leave it in the simplest form. Mathematics always must leave in simplest form. Okay, now this is the simplest form of this expression and you will get full marks for this. Okay, now that's all. Now next part, they ask you, or they tell you that x is changing at the rate of this. Now when you read a sentence, English sentence like that, you must be able to so-called translate this into mathematical language. So x is changing at a rate. Changing at a rate means with respect to time, right? It is the x is changing at this rate. Okay, and this is a so-called real world context kind of question. So there's units involved. So later your answer, when they ask you to find rate of change of y when x equals to 2, they're actually asking you to find dy dt, because rate of change of y when x equals to 2. Okay, so firstly, I know that I'm given this. Okay, then I want to find dy dt. Now dy dt, of course, there isn't any given things about dy dt. So, you know you have to use so-called chain rule, or what I call the ninja split, right? So I split this, and then I need a dummy. The dummy has to be things that you know, dx dt. So it has to be dx because there's no other information given. Okay, so this you actually know is this. Alright, but now we need to find what is dy dx. dy dx, this question is quite nice. In the first part, they already asked you to find dy dx, but if they didn't have the first part here, okay, they simply give you this as part A. You yourself must know that you have to find dy dx by the side here, and then once you know, right, you put it back, you sub x equals to 2 because you want to find dy dt when x equals to 2, so you sub in, you should get this, and remember your units, okay, to 3SF, to 3SF. Alright, so that is all for part 2. Now, the next part is something that is very integral to your syllabus. They expect you to be able to explain, to be able to deduce, to be able to support, verify and all that. So you must train yourself to be able to do that. Actually, it's very simple. It's more or less like showing the actual working, and then you just say a few English words to substantiate or support your answer. Alright, now explain why the curve has one stationary point and state its x coordinate. Now, this question is as good as asking you to find the stationary point of this curve. Alright, but in addition to that, you have to explain. So how do I go about finding a stationary point? I will set the dy dx, because this is talking about curve, right? A curve is in terms of y and x. So you have to find dy dx, which you already found. Now you state this, okay? You state this. Now even if you will realize when you get back your prelim papers, even if this expression is wrong, okay, if there is evidence of you using the part 1 answer and equating it to 0, right, you will get 1 method mark here already. Okay, so never leave blanks. Okay, now next, how do I do or continue from here? That is why it's so important to be able to simplify expressions like I have done in part 1 here. If I simply so-called left it as this times this over this, right, I still have to do some simplification, okay, because right now I need to solve this equation. Okay, now how do I solve this equation? Firstly, we all know that e to the power of 2x, exponential functions, right, it can never be equal to 0. It's always greater than 0, right? Okay, so this is what I have written here. Since this one is always greater than 0, it cannot be equal to 0. So this one, right, you can forget it already. But you need to state this. You need to tell people, right, that, okay, I don't need to consider this. Okay, I maybe have to consider this, but this one is always greater than 0, so no need to bother anymore. Alright, don't understand, ask me. Okay, next, we also know that this fella here, this whole thing, this x square, right, this x square cannot be equal to 0. Okay, but you don't say x square not equal to 0, you just state the range that it can take. Alright, so we know that x square, of course, not equal to 0, it cannot be less than 0, so it has to be greater than 0. And of course, if you times the 3 in front, it will still be greater than 0, okay? So these two, we are trying to tell the marker that this one cannot be equal to 0, cannot. This one cannot be equal to 0, cannot. So only this fella, therefore, only this fella can be equal to 0. And, of course, there's only one x value. Okay? So you see, when they ask you to explain, right, it's no big deal. You do as if you are trying to find this so-called stationary point, right? But of course, along the way, then you say some English things. You tell them, you explain, because explain means right in English, right? So you just say, oh, since there's only one x value when dy dx equals 0, curve has only one stationary point. Okay, when x equals to half, because it asks us to state the value. So that's all you need. Okay, so I hope it's clear. I'm going to go to the next one already. Number 2. Number 2 is show. Okay, show that this is this. This is the most difficult level they can give you in O levels. So not very commonly said, but it'll be good to know just in case. Now, I'm going to start from the left hand side. Of course, have to start from the left hand side. It's not at your level, not possible to go from here to this side. Okay, now I've rewritten this in this form so that you can see the durian in green. Green. So the outermost shell is this one, followed by the black color, which is a tangent function. So this is the fruit the fruit. Then the seed is the red color 2x. Okay, so I'm going to use differentiation now. When I differentiate, right, I bring down the 3 power minus 1, so it becomes like that. So done already. The shell is done. This is the whole shell. Okay, then I need to multiply by the inside, the fruit, which is tangent 2x. Differentiate tangent is secant square, and don't forget that the 2x remains, the argument remains. So this is the fruit. Okay, and finally the innermost is 2x, right? Differentiate 2x is 2, so this is a seed. You combine all the constants together, that's all you get. All right, but you can see that they are different, right? Okay, so you see what they want us to do is tangent power 4 and secant power 2. We have secant power 2x here already. But then you see you have 1, 2, 3 terms, but you only have like one term here, which means you need to so-called break it up, right? Break things up. And the only way you can do that is to use this identity, okay, which can be found in your formula sheet. All right, now the problem now is, do I get rid of this tangent or tangent square, or do I get rid of this secant square? Okay, actually if you're fast you will know but if you don't know, right, then just try just whack. So if I remove the tangent square, I'll get secant square 2x minus 1. Don't forget in your formula sheet, all these are given in A, okay, but you must really change it to 2x, which is the argument that's given here. Okay, then you will end up with this, and then when you multiply in 6 secant square times this, you get secant square secant 4 2x, then 8. But then you realize, oh dear, it's wrong already, right? Because I actually want tangent power 4, but I get secant power 4. Then this is not the answer, okay? Got it? So don't worry, you just try. But don't spend too much time, trying to figure out. You try first, wrong, then you go and change strategy. Now you know already, you must make secant square become tangent 2x plus 1. All right, now let's try this. This one looks more like it, you see. Having the n in mind, the n we want tangent power 4 and so on. So we have this, but then again still not quite right, because this is tangent square, but we have secant here. So again, you apply it one more time and you will be able to get what they want. All right, you should be able to get. You go and try. Okay, now this part done already. Now many of you still very weak in this second part here. Okay, let me just write this down. I'm just transferring whatever is on top, what I've written on top here. When I differentiate this, I get this. Okay, now so when I want to integrate this with respect to x, what should be the answer? Now, where is this located in this first part here? Tangent cube is not tangent power 4, right? So not this one, it's this one, okay? So this is the 主角, the main character of our show. The main character of our show. The rest should be thrown to the other side, including this 6. Okay? But you don't do that first. You demonstrate the understanding to the examiner that you know that when you integrate both sides, okay, this I integrate with respect to x, Okay, I start off here. I integrate this side, this the whole thing, right? This whole thing. And then I integrate this side, is this whole thing, right? Okay. The red portions are exactly what I want, or what the question wants. Okay. The black color ink one is are all the things that I need to throw over to the right hand side. Okay. Now, taking a look at the right hand side first. Right hand side very simple. Right hand side, right? I integrate. I differentiate this and then I integrate. So it's as good as not doing anything, right? It's as good as this. But never mind, you're going to put a plus C, okay? You're going to put a plus C because every time we integrate, there is an arbitrary constant. You just write, you just write it. The C can represent 0, so don't be too bothered by it. But just write, okay? Now, I'm now slowly going to eliminate all the black things from the left-hand side, okay? And I have integrated this already. Integrate secant square is tangent to x, but you must remember, okay? Must remember to differentiate this and divide. Okay, many of you forget in the prelims. Integrate this, you get this. And then because you integrate this whole thing, you get a C constant here. You integrate this, you get a constant here. That's why I have written here C1, C2. Alright, now I'm going to throw everything now. Haven't thrown yet. Okay, sorry. I divide everything by 6. Then this 6 will be gone. This 6 will be gone. This will become another constant. This will become another constant. I didn't write. Oh yeah, I didn't write. Sorry. This one divide by 6. Okay, sorry, I left this out. So must be very careful. Don't be like me. You must divide throughout term by term or divide by 6. Okay, now after you have done that, okay, I have gotten whatever I want already. Throw all this to the right hand side. I'll get this. So that's your answer. Okay, we'll move on. Now, given that the curve y equal fx passes through this one, okay, and it's such that f prime x equals to tangent power 4 2x, find fx. Now, I realize that whenever the question gives you expression in terms of fx and f prime x, some of you get confused. No need to get confused, okay? This fx simply means a function in x. It simply means like maybe y equal x cubed plus 2x, whatever. Okay, so don't be confused or scared by this. No big deal one. This fx is like the y. Then f prime x means you go and differentiate this. Okay? Now, if you were to look at your part 1, then you will realize, or you will think, how come no f1, no f? There's no f in part 1, part 2. Then suddenly there's an f coming out here in part 3. Okay? How are they linked? The linkage is here. Can you see that there's a tangent power 4, whatever here? Okay? And they want us to find fx. They give us f prime x equals this. So to find fx, you have to integrate this, right? Correct? Integrate this, you get this. Correct? And then, you integrate this, you will get this. That's why this question is guiding you, okay? So you integrate this, the answer is already here. Okay? Then you go and okay, I've written here exactly. Then I'm trying to tell you when I integrate both sides, right, I will actually get fx. Correct? Okay, then now here I'm just copying this whole chunk of things I put here. Alright? Okay, then now what am I going to do? Because they want fx, right? This is my fx. Correct? But fx, I cannot say, it's some constant C5. I don't know what. I cannot do that. Cannot do that. That's what sorry. That's why they give us this, you see. This is your like x. Then actually this is your y, right? But y is fx, what? So this is your fx. Alright, clear? Okay, now what I do, right? I sub in. Okay, I sub in. And everybody remember, Calculus means differentiation, integration. Both integration and differentiation, they are under this topic called calculus. Under calculus, your calculator mode must be radians. Okay? Because actually degree is not the correct way to measure angle. It should be radians. Okay? So all these are in radians. Okay? Then you just sub in, then you press calculator, you will get this. So that's your final answer. Okay? Alright, I move on. Okay, question number 3 is on the... Okay, some of the questions here you might have done before, but you know it's good to practice again. CCA also every week you do the same thing, what? Correct or not? So it's about practice. Okay, determine a range of values for which is a decreasing function. Okay, we know that decreasing function means dy dx less than 0. Correct? That's for decreasing function. Cannot forget this. Okay, then how do we do it? So we go and differentiate. Those who did it this way, right, you are making your whole expression very complicated and it's very prone to error. It's not say wrong. It's not say wrong. If you are very strong in your manipulation, right, you can still get the answer, but don't do this, okay? Don't do this. Too complicated already. You're making your life very complicated. Okay, so now we can, I told you can split what? Can split. Okay, so we split this minus this, correct? And isn't it so much easier to just differentiate this, throw down below, differentiate this 4. Minus, throw below, differentiate this 4. Done already. Then they'll give you the marks already. Okay, now after this, right, you set this to be equals to 0. And, okay, this is the part. Now, I suspect many of you, okay, being a bit hardworking, you go expand the denominator. Do not expand the denominator. You are blindly doing things just because you know how to expand, you see. Don't do that. We must be smart. We work smart. So you don't go and expand, because if you expand already, then you still need to factorize. Because in order to solve this inequality, right, this must be in the factorized form. Okay, now let's study this this fella now. You want the left hand side to be less than 0. Okay, left hand side to be less than 0. So don't you agree that this minus 48, the numerator, is already less than 0? Yes, right. This one is already less than 0, right? So in order to keep this whole thing less than 0, this fella must be greater than 0, must be positive. Correct or not? That's why, okay, I wrote here already. That's why for this dy, this whole thing is dy dx. For this dy dx to be less than 0, right, your denominator must be greater than 0. Greater than 0. Okay? So I get x as 7 over 4 minus 7 over 4, x as 5 over 4. Okay? And then I will be able to get this one already. Finish. Okay? So done already. Okay, now let's move on. Number 4 now. Okay, number 4. You have another, some of you will find this very scary looking. No big deal. No big deal. Okay, you must be fearless when you see any maths or science or whatever humanities questions. Given that this, you integrate this whole thing, they are trying to tell you that the answer is this plus a constant. Okay, so they want you to now find fx. Fx is here. What? Is hidden inside this integral sign. That means in order to rescue it, opposite of integrate is differentiate, right? So you must differentiate here. But because you differentiate here, this is an equation, you must differentiate here also, right? So you must differentiate both sides in order to get rid of the integral sign. So what we do is we differentiate. Okay, I'm just writing down the copying down the question for you. Okay, but next step is to differentiate and integrate, differentiate. This whole thing just cancel out, right? So you get this. Now I differentiate this. Differentiate this, right, is, okay, you see this is a function. This is another function. So you use product rule. Okay, differentiate this, same old thing. Actually, there's a 1, but no need to write. Okay, then don't touch this. Then plus, now don't touch this. Differentiate sign, you get cos. Differentiate the fruit, you get 2. Of course, you differentiate a constant, you get 0. No need to write. Okay, now next. I only want fx. I don't want the e power x here. So e power x, I can divide throughout. Okay, I can divide throughout by e power x. Because e power x can never be equal to 0, right? E power x is always greater than 0. So it will never be 0. So it's okay to divide something that is not equal to 0. Okay? Yeah, so this is what I'll get. Done already. So this is my fx. Part 2, they say find the equation of the tangent to the curve at a point where x equals to pi over 4. So what do they mean, or what are they trying to tell us to do? Okay, so if you don't know, you anyhow draw one curve. This is your y equals to fx, and then at a point where x equals to pi over 4, okay, they want the equation of this tangent. So a picture always is good for us to visualize. Okay, you visualize in your brain, it's very draining to your brain, then you don't have energy to do the other questions already. Okay, if they ask you for normal, then is this normal lah? Okay, how to find this one? Remember your dy over dx, right, at this point x equals 4 will be your gradient of this tangent. Alright, and I need this point here. That means I need the gradient of this line, and I need this point here. Okay, so I can sub this into this equation, which is this fella here. This fella here. Okay, then I can get this one. I can get the point, I can get the gradient, then I can find the answer already. Alright, so this is the whole story. Okay, now firstly, I found fx, right? Now I differentiate this fx. Why? Because I want to find the dy dx of this curve, which will give me the gradient of this tangent. Okay, so I differentiate sine, I get cosine 2x. Do not forget to differentiate this. I've said many times, but many of you still forget during prelims. Okay, so differentiate this, you get minus 2 sine x. Again, don't forget to differentiate this. Okay, now after that, combine them together, you get this. Okay, now I sub in this part here. You see this part here, I am very clear in my working. You see how clear I am? I wrote here m tangent. So nobody can fault me. You see, nobody can say, you wrote m, I don't know which m, I don't know whether this is the normal or the tangent. So you write this, the marker will not be able to penalize you. Okay. So I sub in here. Then I get this. Very nice number. You press your calculator. Remember, calculator must be in radian mode. Alright. Then now, at x equals to pi over 4, I'm trying to find the coordinate now. I'm trying to find this point here, okay? This point here. Turns out very nice number. Pi over 4, 1. Then I use y equal ms plus c. Okay, and I'll get the equation of my tangent. Finish already. Alright. Having said this, maybe you want to practice finding the equation of the normal also. Okay. So these are very common questions. Now let's go to number 5. Number 5 is on this what topic is this? Okay, never mind, we will find out later. Okay, so this is hemisphere, whatever. Okay, so this is actually a solid lah. It's a solid thing, but this school, they never draw the whole thing. It's actually a hemisphere, a full hemisphere, and then on top of this whole thing. Actually it's not a full thing. Actually it's correct. Sorry, my fault. Okay, this one is correct. Okay. Then now, given that the total volume is this one, express y in terms of x. Now, very simple, this kind of questions, right? You see what is the quantity that they give you. They say total volume of the whole solid, right? Then you just go ahead and find the total volume of this hemisphere plus the total volume of this cylinder, and then you equate it to 100 pi. Okay, so this is what I do. So you see in A maths, right, all these formulae are not given to you. In E maths it's in the formula sheet, but in A maths it's not given, so you need to know by heart. Okay, so half of a volume of a this part is this part, okay, and this part here I'm using pi r square. The r is the x, then times the h is the y. Okay, so this is your what do you call this thing? Cylinder. Okay, so it's equal to 100 pi. Now you must be very observant. If there is a pi here, you can remove the pi already. Don't waste time writing. Okay, then don't be a hero. Press calculator for this. Okay, 2 square is 2 cube is 8. Press calculator. Then you will get this. Okay, now you want to make y the subject, right? So throw everything to the other side. Divide both sides by x squared, and you end up with this shown already. Alright, now this is important. Okay, let's say this part is wrong, or you don't know how to find this part, right? Can you anyhow write some y equals to whatever, so that you can work on the subsequent parts? Because in your prelim, some of you cannot do the first part, then all your part 2, part 3, you left blank. What a waste, you see. There are method marks to be earned. Alright, so don't lose your marks like that. Okay, now the next one, you will find that the next one very different from the first part, and it's got they ask you to find the total surface area and show that it's this one. Okay, so how to find the total surface area? You look at this shape. I hope you can visualize. The curved surface of the cone, not a cone, sorry, sphere is half of 4 pi r square. So I put half of 4 pi r square. R is 2x, right? So it's 2x square. So this is your so-called this part here, just the outside. Alright, then if you now imagine, you see my pencil, right? Not my pencil, my pen. If I look from the bottom, okay, although this part is hidden, this bottom part is exposed, you see. So actually, if you look at it from the bottom, right, you see a full big circle. So this is my full big circle, pi r square. Okay, pi r square. So what I have is this pi r square. Hey, give me a minute. Wait. Wait, let me think. Messages all coming in. I'm trying to deactivate. Wait. If not, my video will cut off. Okay, done already. What was I saying? Yeah, you look from the bottom. You see one full cycle, which includes this bottom part. When viewed from the bottom, okay, plus the bottom part of this hemisphere. So it's actually a full circle. Alright. So the only part that is not covered now, right, is this curved surface of your cylinder, which when you open up, this is actually your y, and then this is actually your 2 pi r. Okay, 2 pi r, which is your x here. That's why the area, right, is just length times breadth. So it's 2 pi x. Okay, you imagine you roll this rectangle, you will actually get this curved surface of this cylinder. Alright, so this question can come in E maths, can come in A maths. Okay, now we have a big problem here, and the big problem is that the thing that they want us to show, right, has only x inside, no y. So this y has to go, which is why the first part, right, they actually ask you to find the y. Okay, so now your job, after you have expanded this, then this one can be combined together to get 12, right? You replace this y with this. Okay, then that will give you this thing here. So this 12 is just this 12. Then I take this times this, I get this. Then I somehow manipulate. Then I will be able to get this. Exactly what they want me to get. Okay? So that's all for the second part. Now for the next part, oh, I didn't copy the question. Let me see what's the question now. Wait. This question number. Okay, they ask us, they say that given that x can vary. Okay, x can vary. Now, I was explaining to somebody yesterday. X can vary means, right, you can, that means the x value here can change one. And because the x value can change, the a will change accordingly also. That means what they're trying to tell you, right, whenever they say x can vary, they're trying to tell you you can differentiate a with respect to x. So they can find dA dx. Okay, and when you set dA dx to 0, you will be able to find the stationary value. And then using either the first or second derivative test, you can get your maximum or minimum value. Okay, so I've differentiated these. Now, when I differentiate these, I don't work from here. We all know that this is my A, right? I don't work from here. I work from here, you see. So you see, I bring the 2 down. This one don't touch. Power minus 1. Alright? Then this fella is 200x. Sorry, pi. I write the pi first. Then x minus 1, right? I bring the x up. This one will give me this. Okay? Some of you are still using quotient rule for this kind of things. Don't use quotient rule. You're complicating your life. That's why A maths is very difficult to you. Okay? It's in the form ax to the power n. So differentiate like that easier. Okay? Then write it in this form. And then now you set it to 0. Set it to 0. And then you see I combine them together. And because this cannot be equal to 0, right? This one 0, then this whole thing not defined already. So because this is not equal to 0, so the numerator must be the one that's equals to 0. And then you can work out the answer already. Okay? And because this expression is very easy to differentiate again. Very easy to differentiate again. So I differentiated again. Then I sub in, class. I only sub in the x equals 4 point whatever here, right? So I put a bracket here to tell me that I'm substituting in this value here. Okay? So I get this value, and because it's greater than 0, you turn this around, so it is a minimum point or minimum value. Minimum A. Okay, done already? Okay, so that's all. Now let's move on to question number 6. Question number 6 is on don't know what. We take a look at it. Okay, so show that the area is given by this. They shows two rectangles, A, B, C, D. Okay, A, B, C, D, and A, E, F, G. Then they give you 8 4 whatever. They just check that everything is given. The only thing that you need to work on is this fella here. Okay, this is not indicated on your diagram, so you need to do something with this to form an equation. Now show that area of ABCD, the big one, is this one. Okay, I think we have done this before, yes. Some of you even asked me how to do that time. And why are we doing again? I'm doing again because many people cannot do that time, and for some of you, maybe this is the first time you see this question. So let's do it again. I think it's from some girls' school, maybe Crescent Girls. Okay, show that it's like that. Okay, how to show A, B, C, D. Now, firstly, you will notice that, I know this is x plus 4, but I don't know this. I don't know this because I don't know this. So if I can find AE, right, then my problem is solved. So that's how you think, you see. So that's how you think. So how to find AE? AE belongs to this rectangle, but this rectangle they already told us is 72, so we can work on that. So AE times the x will give us 72, which means I can find AE in terms of x. That's a good start. Why is it a good start? Because now I can sub this into here. Alright, into here, and that will give me length, length times breadth, which is what I'm doing here. It looks a bit complicated, but you do slowly, you can find the answer. Okay, so that's all proven already. Okay, now again they say x can vary. What do you mean by x can vary? They're trying to tell you, this one can change, meaning this can change also. So you can differentiate. Okay, this is called the rate of change kind of thing. So find the value of x such that it is a minimum. Okay, never mind. We don't care minimum or maximum. We go and differentiate first. Take note, this means 288 x to the power minus 1. Okay, now when you differentiate, power bring down, power minus 1, that's why you get this. And of course, this will disappear. This is just 8. Now equate, Oh, I haven't found, okay. Okay, sorry. This part here should be here, should be here, okay? Yeah, so, because they asked me find the value of x, so the x value should be this one. I have to reject this, Okay, sorry about that, this one, I think you all know what's going on. And then after that, right, I have to do the last part. Prove that it's a minimum. I didn't prove, Okay, I think blur already. Okay, so this is my part 3, Part 3, you have to prove that it's a minimum, so I can differentiate again. This one, right? d2a dx square. This one, just be very careful that it's minus 288x to the power minus 2. So I have, differentiate this is 0, right? Then differentiate this will give me 288. 288 times 2 is 576. So it is 576 x to the power minus 3. Okay, then you so-called throw it down below. And then when you sub in your 6, equals to 576 over 6 cubed when x equals 6, right? Then you get some value. See, positive over positive, surely it is greater than 0. So greater than 0 means minimum. Okay, so therefore A is minimum. Okay, sorry for the can you go and do yourself. Okay, then the last part is this one. That time I think many of you not very sure about this one. Okay, so they are saying now that N says that A is minimum when the rectangles A, B, C, are similar. Do you agree? Verify your answer. So you have to understand that this question is linked to the previous part. Alright? A is minimum when so you think back, A is minimum when A is minimum. Go back in time, okay? A is minimum. Oh, when will A be minimum? Oh, when x equals 6, right? When x equals 6, just now we proven, right? So when x equals to 6, then A is minimum. So this x equals to 6, right, is very important to help you solve this question. If you don't know that x equals 6, then you'll just be staring at this question, or you'll be doing the whole thing all over again. Okay, so when A is minimum, what they're trying to tell you is x is 6, but they never tell you very clearly, very explicitly. You see, they want you to infer from the previous part. Okay, so when x equals to 6, right, you use the diagram that you are given here. Okay, here. When x equals 6, so this will be 10, this will be 6, this will be don't know what you take 72 divided by 6, that's 12 12 here. Okay, so you're going to work out whether you take AG, that means the ratio, the square of the ratio of the side size. AG, that's a small one, AD is a big one, right? So L1 over L2 square. Okay, you go and check whether it's exactly the same as when you go and find the area of the actual rectangles. You already know the small one is 200. you can now find the big one. That's what I've done here. Then I find that, oh yeah, the ratios are the same. So I explain here lor. Because you know why not? Because they asked me to explain, you see. They verify your answer, or they can say explain your answer. So I am now explaining to them that, oh, because the ratio of the sides is equals to the actual ratio of the areas, so A is minimum. That means x is equal to 6 alright, when the rectangle are similar. Okay, you got it? Can okay, so that is all. If you don't understand, you ask me, okay? Because I think this question posed quite a challenge for some of you that time when we did it during the June holidays. Okay, now this kind of question, okay, this one I show you everything. This kind of question, we've done it many times, but during the prelim, right, still many of you how to say, you firstly never read question properly, then you messed up. Never mind, I'll show you when we do corrections. We'll be doing the corrections next week, okay? As in the September holiday week, not when school open. School open, I'm not doing the corrections. School open, we are doing some other papers, okay? Now, this fella, sorry, the first part is this one. Okay, express this in partial fractions. So you see, firstly, you have to see whether it's proper fraction or not. It is not proper fraction because your degree of the numerator is the same as the degree of the denominator, because this times this later will be x cubed. So you have to do long division first. Okay, you have to do long division first. But before you do long division, of course, you got to expand this. Okay, don't make any careless mistake. It's worthwhile checking before you go and do this. Otherwise, all wrong. Then no point, right? Okay, so you expand already. Then you take this numerator divided by denominator. Okay, and remember, always minus. Some of you during prelim you go and plus, then wrong already. Okay. Then now how to interpret this result? This is your quotient put here. Alright. Then the leftover is this, right? And it is was actually divided by this fella, right? So put here. Okay. Now this is the one that you need to express in partial fractions. Okay. Now what you all did in the prelim, quite a few of you, is you straight away this one split into this form, then it's 0 already. You straight away this go into this 0. Okay. Now let's see how to continue. This whole thing, right, you must remember, multiply by this. Okay, then you end up with this, and then you sub, then you get the answer. Remember, don't be too caught up with this ABC and then you only leave this as the answers. How you did that in the exam. There must be a 2 here because originally it was a 2 there. Okay, you only did partial fractions to this. Then the 2 must be there. Okay, so if you're lazy to copy this whole thing, you're very lazy, right? Then you just write therefore or rest right answer like that, save time. Alright, now the next part is like what I told you, very commonly said. They ask you express in partial fraction already, then they ask you to integrate this fella. Okay, now see carefully, okay, during the prelims, they ask you to do this, right? But they ask you to integrate something here, then with a 2 here. With a 2 here means your everything here must be divided by 2. Okay, we'll discuss when we do the corrections, but I just want you to be very aware. See carefully what you have originally and see carefully what the question wants you to do for part 2. Okay, if there's a 3 here, put 3 here. If there's a 2 here, divide by 2 throughout. Understand? Okay, now what I'm going to do, right, is simply changing this, which is equals to this, here, like that. Okay, and now I'm going to integrate this, purely just integration. You need to know how to integrate 2, then you just get x. Okay, this fella, right, I told you already, if it is like power plus 1, then you go and divide by 0, cannot, right? That means it's a long thing. But okay, many of you remember that it's a long thing, but you forget to divide by the differentiated fruit. You must differentiate this 2x minus 1 to get 2, and then you divide. Same here, you must differentiate x plus 5, that's why it's 1. This one is different, okay? This one, you can, the minus is this minus, you can actually plus 1, okay, that will give you minus 1, then divide the new power, right? Okay, then differentiate this, you get 1. So this one not a long function, then you get this, then you do to get the answer. Now, those of you who are just watching this video and not trying at all, you really have to spend some time, right, practicing. You go and ask your friends, those who really try, right, many a times they couldn't get the same answer as, okay, this one, in this question they ask you to prove lah, but many a times they can't get the same answer as me. Alright, that's because it takes skill to press calculator and to do all this manipulation. So do practice, okay? Now, I would just like to emphasize certain things. You see the question asks you to prove this, right? You will notice that, oh, there's a number, then how come there's a law here, then there's a law here, why they never mix them? They are trying to test whether you know how to manipulate in the way that they want you to manipulate or not. Okay, so it's worth trying this question. Okay, you see how it goes. There's a 3 here, and I know that when I bring this up here, I get 27. That's why I left this alone. This fella here will suddenly later become this fella here, you see, by doing this. Okay, and of course, by power observation, this one when I bring up is 49, and this one, when I bring up, it is 36. That's why these two will give me this. And of course, the rest will give this. Okay, you go and try it out. Alright, next one, number 8 already. Okay, number 8, we are moving into this area domain already, area. Okay, so it's like the heaven minus the earth kind of thing. Okay, the diagram shows the graph, okay, like that. Okay, so they didn't tell you which graph is which. So you yourself need to know that this is a quadratic. Quadratic is this black one. Okay, this black one right here, black. Okay, this looks very funny, right? How come x is the 主角, but then you see, all the rest seems to be the same as this other quadratic equation, except the x became the y. So this is what we call, it's not in your syllabus, it's actually a flipped graph, flipped graph. You imagine this y equal x, right? You flip this quadratic curve, like a mirror, using this as the mirror, then you will get this. Okay, so this is actually the green one. And of course, everybody should know that this is your y equals to x, this is the red one. Alright, now how to find the, okay, read carefully, this question, they only want the x coordinates, they don't want the coordinates. That means they don't need the y value, so don't waste time finding the y value. You're just wasting your time in the exam. Okay, now submit, then you get this. Alright, now remember, in the exam, please show this working. In your prelims, you don't show this working, we still give you the marks, but in the O level, they may penalize you. So now we know that x equals to 1 or 2. So it is a good practice to label here 1, label here 2. Okay, now next, find the area bounded by the curve and the line, this one. So you want the quadratic, that means is this shaded area lah, So the heaven is the red line, the earth is this. Okay, so if you imagine yourself here, the man, you imagine your heaven and earth throughout the journey is the same, right? So you integrate from 1 to 2. Why 1 to 2? There, 1 to 2. Okay, then the heaven and the earth throughout your walk here to here is the same. So there is no need to do any other integration here. Okay, then you just simplify this. Be very careful here, minus, minus, minus. Alright, now many of you you just minus the first one, then the rest you forget in your prelim exam. So this is a very common mistake. Okay, integrate, then you should get half. Please check, okay? Now the next one, they ask you, deduce. These are the kind of questions, class. These are the kind of questions you will see in your O-level examination, like explain, deduce, whatever. A few questions are not all. So for this kind of questions, right, you don't be scared. You just do as if you are doing as per normal. But then you write some English words to so-called explain or deduce or whatever. Lor. Okay, so you look at the marks. For this question, it's 2 marks. So you need to tell them, right, a little bit more. Okay, or you need to show a little bit more working. But if it's a 1 mark question, then you can straight away deduce and then just write the answer. Okay, but a little bit of explanation won't harm lah, because it's actually quite easy to deduce. Okay, now deduce the area bounded by the circle, whatever. Okay, so my explanation you see is there. I would just like to draw your attention to this curve here. Now this curve here, this one and this one right here and here. Okay, my curve is actually not very good. My curve is not very good, so I'm going to wait. Bring you back to this actual drawing here. Okay, now you see from afar, it's a heart shape, right? It's a heart shape like that. Heart shape like that. Half of a heart, right? So can you see that it's being flipped over? If I want the area bounded by the line and this curve, it's actually this white portion here. And don't you agree that this white portion is actually the mirror image of this portion here? So that's what I'm trying to say in the sentences you see here, okay? Since the curve is a reflection of the other curve. You see, these 2 curves are different. But I say it's a reflection, you see? And I must say, reflect about what line? When I say about what line, that means this is the mirror line. Mirror, you know the mirror? Like a physics mirror. Okay, so I'm trying to tell them that, oh, it's a reflection only. Okay, the bounded area, right, is actually equals to the area in part 2, which is half unit square. Okay, yeah, so that's all. Alright, okay, now you can actually say that it's actually a reflected area. This area seems to be reflected about this line y equals x. Okay, yeah, this is also fine. Alright, now let's go to number 9. We are left with, I think, 3 questions and then that's it. Okay, I'm trying to cover all. So sorry for it's almost 1 hour. The diagram shows okay, so this is the curve, then this is the line, but this is not anyhow one line. This line, there's a meaning to it. So I tell you, class, this prelim exam, you're going to look at your mistakes, right? Many of you lost marks because you didn't read the question carefully. So you must read the question carefully. Don't just skim through and then rush into the question. No. Read carefully what they want and what's the story, okay? Now, A lines on the curve, okay? The x-coordinate is this one, okay? Already here, right? And the normal. So this is the normal, very important information. That means you need to find later the tangent. Tangent. Because only from the tangent, which is dy dx, the m, right, tangent, only from here, when you sub x equals to pi over 2, then you can get this gradient. And only once you get this gradient, then you can get this gradient. Okay? You cannot straight away get this gradient. Cannot. You must find this gradient, then can get this gradient. Okay? Because this is 90 degrees. Okay, now let's start. Find the coordinates of B and C, leaving your answer in exact form. Okay. To find coordinates of B and C, very straightforward. We just need the equation of this line. Then here, I'm on the y-axis. I must have some y value, right? Must be minus something, right? So this must be, the x value must be 0, okay? Similarly, my B, I'm on the x-axis. So I must have some x value. That means my y value is 0. So later you sub x equals 0, you get this. You sub y equals 0, you get this point. Okay? So that's what I'm going to do. Again, please, make sure your calculator is in the radian mode. For integration, differentiation questions, your calculator must be in the radian mode. Differentiate cos, you get minus sign. The doggy remains, okay? Many of you think of the doggy as a function. Very scary. Some of you, when you differentiate this, right, you use product rule. Don't. Okay, okay, now this fella here, right, x over 3 is actually just 1/3 x. This is the doggy. Okay, then I differentiate this, right, then I get 1/3 lor. That's all. Then I combine the constants together, I get this. Now after I've done this, right, this will help me to get my tangent gradient. So at x equal to, I find my tangent, the gradient of my tangent, and from my gradient of the tangent, I can find the normal. Now, I want all of you to write these two down very clearly in your working, because in all the years of O-level, they give marks for this. They somehow, to them, this is very important. So please write this. Then when you, okay, I found the gradient. You see, I found the gradient of this line. Okay, this normal. Now I need to find this point. So what do? I sub. Then later I can find already. That's all. Okay, so this is my gradient of the normal. And once I have the gradient of this normal, as I mentioned to you just now, you sub x equals 0, you get the C. Sub x equals to y, y equals 0, you get the B. That's all. Okay, that's all. Okay, now we move to the second last question. Okay, I'm going faster in this series of videos compared to June, because we really have no time already. June still can slow down for everybody who is not. You read. Slow down for everybody who is not there yet. Now everybody should be more or less there already. Okay. If you're not there, please see me for Zoom these holidays. Okay. This is your velocity. The particle comes to instantaneous rest at A and a little later at B. So it means this particle, right, it moves. It moves a point O. It moves from a point O. Then don't know whether turn left or turn right, but it doesn't matter. Okay, it doesn't matter. Many of us or many of you will ask me, hey, did you go left first or right first? It doesn't matter. Okay, you just assume one direction first. But of course, if your S works out to be positive, then by convention we say it's to the right. If your S works out to negative, right, then by convention it's to the left. Okay. But if in the first place you don't know, right, then it can be left or right. But normally we go right. Okay. We assume the particle go right. Okay. So let's say the particle starts at O, right? Then it moves at point A. It stops. So A, it stops. Stops to do what? Must be U-turn. B, but the B, right, can be here or can be here. We don't know where. Only later, after we have found the S, if S is positive, it's this side. If S is negative, then it's the left-hand side. Okay? So don't be too concerned about this first. You just do the first part. Find the acceleration of the particle at A. Do we know what is going on at A? Yes. We know that at A, it was at rest. At rest means velocity equals 0. Okay, everybody? So this is important. It is important. Now, after you have done this, then now do what? Okay, after you have done this, we first of all find the acceleration formula, which is this. Acceleration, I differentiate this. Differentiate this. Remember this. If you don't know, please write in this form somewhere as rough working. Okay. So power bring down, then power minus 1, become like that. Then remember, must multiply by the t plus 1 differentiated fruit, which is 1, but I don't write. Okay, so this is your A. And you see, I box it up because it's very important. But now, you see, we don't know what's the t. We don't know what's the t. So, in order to get the t, you must get it from this clue here. B equals 0. So, I sub B equals 0. Then I can get the answer already, okay? Now, B equals 0, you get two different answers. And rightly so, because they say that the particle comes to rest at 2. 2 at A and then at B. So now we want A, right? We want A, so it must be the smaller timing. So this must be A, this must be B. Alright, so at A, I wrote here T equal 1 and then get the answer. Please remember to write your units. Finish. So that's for part 1. Now let's do part 2. Now part 2, calculate the distance. Now whenever they say distance, you know it has to do with displacement, right? So you have to find the S formula from this. Okay, now for those of you who don't know, SVA, displacement, velocity, acceleration. To go this way, you differentiate with respect to time. To go the other way, you integrate with respect to time. Okay? Got it? Some of you still don't know this. Hey, very, very sad. You need to see me, okay? You need to see me. No time already. Okay, then I integrate this whole thing. Okay, then I rewrite this in this form easier, you see. Then now you see, this one no problem. Power plus 1 divided by 2. Okay, this one power plus 1 is 0 divided by cannot, right? So it's a ln function and you must differentiate the fruit divided by the fruit. And you must plus C. Okay, a number of you forgot to plus C in your prelims. -1 mark. Alright? And -1 mark is for those purely integration question. For this kind, your C will affect all your other answers. Alright? Okay, how to find the C? You always go back to the initial condition. Initially, when t equals to 0, the particle was at O, which is S equals 0. So you sub in, then get the answer here. Alright? So many of you, I tell you, this kind of questions, right? You will die without knowing why if you don't find the C. Because the C is 0, So down here you don't put C, right? You get the same answer as your friend. Then you high five your friend correct, full marks, you don't get full marks because you never find the C. So remember, you must find the C. Okay, now I'm trying to find the distance between A and B. So just now we mentioned already, A, the T is 1, B, the T is 7. So you have to find T equal 1, T equals 7. Alright, then you can get this diagram. Now this diagram is very important. You need to draw this diagram so that you can find the distance. So you see, it tells us that, when T equal 1, that's why it went right first. It went right. Then stop. Stop to do what? Stop to U-turn. Okay? Then down here again, stop. Stop to do what? Stop to U-turn. Like that. Okay? So I don't know where you go after that. So can you see that your distance is this 1 time, 2 times, this and this same distance, right? Then down here, okay, don't talk about this. Down here to here is just this, right? So this is the answer. Okay, that's all. Okay, now we move on to the last part of this particular question. Showing your working, explain why the particle is again at O sometime during the 3rd second. Now, this particular question, those of you who tried this question, very good. Those, please, those who tried, listen carefully. Those who tried, right, you check whether your working is the same as mine. You may think your answer is right, but if your working is not the same as mine, then your working is wrong. Okay? Those who never try, you may think, like that only very easy, right? If you were to try on your own, right, you may not have the same working as me. Okay, so this is a question where it tests you on English a little bit. Showing your working, explain why the particle is again at O at some instant. They didn't tell you what's the, at some instant means at some time during the 3rd second. Now what is the meaning of the 3rd second? We have explained this before. 3rd second means from t equals 2 seconds to t equals 3 seconds. This is the meaning of the 3rd second. Alright, so it means that when the particle travels from t equal 2 to t equal 3, in between at some instant, right, don't know when, nobody knows, the particle actually was at O again. So that's what the question wants you to explain. So are you able to explain? Those who haven't tried, you may want to try now. Okay, so at t equals to 2, I find the answer. for s. At t equals to 3, I find the s. Oh, then I conclude that, oh, at t equals to 2, it's positive. That I told you just now already, what? I told you just now that, okay, not this one. T equals 2, right? The s is positive. T equals, that means t equals 2, like that, and then t equals 3, t equals to 3, right? The s is negative. So it must have passed by this fella in between t equals 2 seconds and t equals 3 seconds, right? So that's what they want you to say or show. So I say here, since displacement changes sign from t equal to 0, t equal to 2 to t equal to 3 seconds, the displacement for the particle must have been 0 at some instant. Okay? So displacement equals 0, s equals 0, means the particle was at O lor. Okay, so this is how you should explain. So this question actually is not easy to explain. Alright, so it will be good to try for those who have not tried lah. Okay, now is this the last question already? Yeah, I think this is the last question. Okay, not difficult lah, this last question. Two particles that leave a point at the same time. Okay, they leave at the same time and they travel along the same straight line. Particle A starts from rest and travels with a uniform velocity of this one. Alright, so they didn't give us what you call that? They didn't give us the S, the V they give us, the V is half and it's a constant speed. There's no T. Is there a T here? No, there's no, it's uniform. So the V, if you want to write, the VA for this question, the VA for this question is just half. Alright, the VB they did give us this, and T is the second after leaving O. Okay, so now let's see, calculate the initial. Initial always means T equals 0. Okay, acceleration, do we have acceleration formula? Don't have, but they give us the VB. So AB, you see, class, for questions involving two particles, you must label whether it's A or B. Okay? Otherwise, later you will confuse yourself. The examiner normally very nice, they won't minus your marks if it's within this section that you're answering for B. But you will confuse yourself later if you need this. Alright? So I differentiate. I get this. Okay, I think you can get. Then I box it up because I will need it later, most probably. Now next. At t equals 0, I sub in, and that is my answer. Please remember to write your units. Okay, now next part. Find the value of B when find the value of T when B is instantaneously at rest. Okay, this one also very easy lah. You just set this to 0. You do. You should get this. And you must always remember, no negative time. No such thing as negative time. Okay. Now next. Find the average speed. Okay, find average speed of B during the first 3 seconds. Okay, which means I need to find the S for B, right? So I find this. Then remember, must find C. Although the C is 0, you must still, C is not 0, C is minus 3, you see? In this case, it's minus 3, like that, okay? You find, this part is important, many of you still not really doing this. You must always find, when they ask you for the first 3 seconds, right? You must find from 0 all the way to 3. You cannot ignore 0, because sometimes 0, right? S is not 0 one, you know. Okay, please, this you must do. Okay, then you must do the diagram later, this diagram. Alright, so in this case, very nicely, when t equals 0, s equals 0, then boom. At t equals 2/3, where was it? It was, you see, this question, it went left. So the s will tell you whether go left or go right. So it went left first, then it went at t equals 3 seconds to here. So it goes like that. So there is one part here, two part here that's the same. Then this is another part that is different. Then for average speed is total distance divided by total time. That's what you get here. Alright. Lastly, collision. Okay, we're coming to the end already. Okay, before I do this question, I don't want to forget to say this later. do not ask your tuition teacher to go through with you the prelim paper for E-maths, A-maths. Don't, okay? It's a waste of time. I'll be going through in these videos with you. Don't waste time asking your tuition teacher to go through with you. Ask your tuition teacher to do other questions with you. Okay? Otherwise, you're wasting time because I'm going to go through anyway with you and it's free one. I'm give you free one. Okay? If you don't understand after my video, then you PM me or you Zoom with me. Okay? Okay, that's all. Find the distance from O when particle B first collide with particle A. So what are they trying to say? These two objects, if you had read the question just now, right? They start off from the same time. Okay? Start off at the same time along the same line. So the pong, pong, like racing like that. So of course, don't know how they go, but later, right, they will collide with each other. Maybe this fellow U-turn and then they collide already. Okay? So when they collide, the distance that they travel is not the same. The distance of A and distance of B, right, may not be the same. Okay? Because I travel more than you, then I U-turn, then you are still coming this way. Alright? Then we meet, I travel more than you, so we are not equal. But the S is definitely equal. Because S is how far we are from the point O. Okay, so our reference point O, we are the same distance from our reference point O when we meet or when we collide. Okay, so this is definitely the same. So this is what I've done here. Now, this part here maybe requires a bit of thinking. For the distance covered, do you agree that it is this one? Alright, and do you agree with this this solution? Okay, I'm just going to show you this solution and I'll leave it as this. Okay, if anybody disagree with me, okay, wait. Anybody disagree with me this solution, right? Then you just let me know. Okay, those who agree one, you agree, then you agree. Okay, if you disagree, then you let me know. Okay, so this is the solution that I've done. Correct or not, I don't know. You go and figure it out. Okay, that's all. Thank you. Sorry for such a long one.